Hello, future engineers. This is the last part, second part of problems on machines. Determine the force P which must be applied at A, here, in order to support the 100 kilogram crate. There are two of every member shown with connecting members perpendicular to the paper or to the screen at every joint, and a light platform bridges the two members DE. Friction at the joints is negligible and all members are light. Friction beneath member CF is sufficient to prevent slippage. So remember the hint that there are two of every member shown with connecting members. So first, let's draw the free body diagram of this portion D. So call that FPD, FCD, FTE, then this is also FTE, FEF. These two are parallel because if this is 130 mm, this should also be 130 mm, originally vertical. That's why the horizontal distance CD is 610, and this is the center of gravity. DE is also 610. So that's FDE. Theta BD is the angle that BD makes with the horizontal, is equal to arctan of, use your calculator there, 190 minus 76 divided by 70 plus 130, so that would be 200. Remember, horizontal distance between CD is also horizontal distance between EF. So 130 plus 70. So again, arctan of 190 minus 76 over 70 plus 130 is 200. So 29.683 degrees. While theta CD, which is also theta EF, is arctan of 76 over 130, and that is equal to 30.311. So we consider DE, we set, so this is also 305, half of 610. So moment D0 to solve for FEF. The only component of FEF that has moment about D is the vertical component, and that is equal to counterclockwise positive FEF sine of 30.311 degrees. The moment arm is 610. Then minus the weight, which is not shown here, but it is given 100 times 9.81 times 305. So therefore, FEF is equal to 971.88 newtons. Take note that there are two of every member, so we will just distribute P later. So it should be P over 2 because there are two of every member in solving for P later. So for the meantime, that's FEF. RE horizontal equals 0 to solve for FDE here. So we have FEF 971.88 cosine of 30.311, the horizontal component of FEF at E, then minus FDE. So from here we can solve FDE equal to 839.02 newtons. Then RD horizontal at D, horizontal component of the resultant horizontal component at T is 0. So we have equals 839.02 FDE minus FBD. The horizontal component is FBD cosine of 29.683 83 degrees, then minus FCD cosine of 30.311. So simplifying this equation, we have FED cosine of 29.683 degrees plus FCD cosine of 30.311 degrees equals 839.02. Call that equation 1. Then R vertical equals 0 at D, or F vertical component of FBD is FBD sine of 29.683 degrees, then minus FCD sine of 30.311 degrees, the vertical component of FCD. So FCD therefore is 0.9812 of FBD. Substitute in equation 1. So FBD cosine of 29.683 degrees plus quantity 0.9812 FBD cosine of 30.311 degrees equals 839.02. We only need FBD because our last plan is to set moment at C0 considering this arm. So FBD is 488.98 newtons. Finally, we draw the free body diagram of this arm. And take note that since there are two members, there are two arms also. We divide P by 2. So 675 plus 190, that's 865 mm. So the free body diagram for 88.98, that's FBD. These are the two forces, but plus the pin reaction at C, but we set moment C, so these are not important anymore. And moment C0, considering counterclockwise positive, so equals, so I now divide P by 2, so P over 2 times 865, 675 plus 190, because there are two per member, then plus the vertical component, which is also counterclockwise. The vertical component of 488.98 is 488.98 sine of 29.683, moment arm 70. 488.98 sine of 29.683 times 70. Then minus the moment of the horizontal component, which is clockwise. The moment arm is 190, so minus 488.98 cosine of 29.683 degrees times 190. So from here, we can now solve for P, which is the required value. So P is 147.4 newtons. In the special position shown for the log hoist, booms AF and EG are at right angles to one another, and AF is perpendicular to AB. So AF is perpendicular to AB, this one. If the hoist is handling a log weighing 4,800 pounds, compute the forces supported by the pins at A and D in this one position due to the weight of the log. So for the solution, let's have the free body diagram. Let's call the force on this support as FDE. The force at D is also the force at E. Then the angle it makes with this AF is equal to, because this is 8 feet, 2 feet, 24, 12 inches or 1 foot. So arc tan of 1 foot over 8. So these are the component reactions at F because we plan to sum up moments at F. So this is the weight of the log. And this is 10, hypotenuse 10 feet, sine of this angle, which is also 45 degrees. So 10 sine 45 degrees. Then the angle that FDE makes with this axis parallel to AF is arctan again of 1 foot, because that's 2 feet minus 1 foot. So 1 foot over 8 is arctan of 1 over 8 is 7.125 degrees. So the component along this axis is FDE cosine of 7.125 degrees, and the moment arm is 2 feet. The component parallel to this direction passes through F, so it has no moment at F. So moment F0, clockwise positive, so equals FDE cosine of 7.125 degrees times 2, then minus 4,800 times 10 sine 45. So from there we can solve FDE, which is equal to 17,103 pounds. Therefore, the force at D, which is equal to the force at E, is 17,103 pounds. Next, we consider the free body diagram of this entire part, considering A and B, the force at C. So A and this force, we will not touch that part. So this is now the FBD for the second part. We may move FBC here if we want to. So the angle again that FBC makes with AF is, because that's 4 feet and this is 12 feet, so that means distance from C to A parallel to AF is 8 feet also. And because that's 12 inches or 1 foot and this is 24 inches or 2 feet, so again this distance is 1 foot again. So the angle with the line AF that BC makes is also 7.125 degrees. These are the reaction components at A, and this angle is still 7.125 degrees. So this time there are two components along AF and parallel to this arm, and the moment arm is 8 feet. So this angle therefore is 45 degrees minus 7.125 degrees, so that's 37.875 degrees. Then for 4,800 pounds, the total distance to point A, because we plan to set moment A0, is 10 sine 45 plus 12. This is 12 feet sine 45. So 10 plus 12 sine 45 is 22 sine 45 degrees. So set moment A0. Counterclockwise positive. So let's begin with FBC cosine of 7.125 degrees. The moment arm is 1 foot. This distance is 1 foot or 12 inches. Then the component in that direction is FBC sine of 7.125 degrees. The moment arm is 8 feet. 12 minus 4 feet. So 8 feet. And it is also counterclockwise. So plus FBC sine of 7.125 degrees times 8 feet. Then minus 4,800 times 22 sine 45. So from here we can solve FBC. FBC is 37626 pounds. Then R horizontal 0. So that is equal to horizontal component of FBC is rightward. It is FBC sine of 37.875 rightward. Then minus AH. So AH is equal to 23,100 pounds leftward. Then R vertical equals 0. and that is equal to vertical component of FBC is FBC cosine of 37,626 cosine of 37.875 degrees, then minus AV minus 4,800. So A sub V is equal to 24,900 pounds. Finally, the force at A, FA, is square root of 23,100 square plus 24,900 square. So FA is equal to 33,965 pounds. The knurling tool produces a knurled gripping surface on the rotating shaft A in the lathe. The force exerted on the shaft by the imprinting rollers B produced by the adjusting screw C, and the force F exerted by the lathe tool post on the pivoted shank of the knurling tool. If screw C is under a tension of 1.2 kilonewtons for the configuration shown, determine the tool post force F and the force P supported by the bearing on its knurling roller B. So P is the force at B. So let's draw the free body diagram of this portion. Let's transmit the force and the tension, and as a result it will react. That's FB, or that is P supposedly. Then we have reaction components at O. This angle is equal to arctan of, from the vertical, arctan of 20 over 43, where 43 is half of 86. So 24.944 degrees. So reaction components at O, we set moment O0 and counterclockwise positive. So beginning with the horizontal component, counterclockwise, vertical component, counterclockwise also. For the horizontal component, it is equal to FB sine of 24.944 degrees. The moment arm is 43, again half of 86. This vertical distance, 43. The vertical component is also counterclockwise, so plus FB cosine of 24.944 degrees, moment arm is 64. Then minus 1.2 times 80. So from there we can now solve FB, which is supposedly P, and it is equal to 1.26 kilonewtons. So FB equals P equals 1.26 kilonewtons. Then we draw the free body diagram of this entire figure. So the horizontal component of FB is FB sine of 24.944. So 1.26 sine of 24.944 degrees. This is also 1.26 sine of 24.944 degrees, and that's F. Since this is internal, we do not touch it. So our horizontal is just 0. These are the other components which will not affect the value of F. So our horizontal equals 0. So 2 times 1.26 sine of 24.944 degrees minus F. So F is 1.063 kilonewtons. The upper jaw D of the toggle press slides with negligible friction resistance along the fixed vertical column here. So it's free to slide. Calculate the compressive force R exerted on the cylinder E here, and the force supported by the pin at A. If a force F is 200 newtons, force F of 200 newtons is applied to the handle at an angle of, this angle is 75 degrees. So if this is 75 degrees, this is 90 minus 75, so 15 degrees. 15 degrees. This is vertical and this is inclined, and this is an isosceles triangle, so this is also 15 degrees. So the angle at B is 180 minus 15 minus 15, 150 degrees. So if AB is extended, the angle it makes with, if BC rather is extended, the angle that it makes with AB would be 180 minus 150, so 30 degrees. So call that FBC in compression. Then if extended, the measure of this angle is 30 degrees. That one. 30 degrees is 180 minus 15 minus 15, because that's 15 degrees. This is also 15 degrees because this is an isosceles triangle and we have a common vertical here. So that's why it's 30 degrees. Therefore, this moment arm of FBC, when we plan to take moment about summation moment about A, is 100 hypotenuse sine of 30. 100 sine 30 is 50 mm. So that's 50 mm. And F is 200 newtons. The perpendicular distance to A is 250. So therefore, these are the reaction components at A. Moment A 0, clockwise positive, so equals FBC times 50, then minus 200 times 250. So from there, we can solve FBC equal to 1000 newtons. Having found FBC, then we do the FBD of the lower part, or we solve for AH. So take note that this is 15 degrees angle between the vertical and this inclined parallel to the force F. So FBC makes an angle of 15 degrees with the vertical also. So this is 1000. We transmit it now to C, and the angle it makes with the vertical is 15 degrees. And this is the reaction R. So summation forces vertical, or R vertical, equals 0 in this free body diagram. Take note that there's no resistance, no friction. The upper jaw is free to slide on this fixed column here. So therefore, R is just 1000 R minus 1000 cosine of 15, the vertical component of 1000. So R can now be solved. It is equal to 965.9 newtons. Then for the magnitude of the force at pin A, let's go back to this free body diagram. R horizontal equals 0. So we have EH, then horizontal component of FBC is going to the left, so minus 1000 sine of 15. Then horizontal component of F is also going to the left, so minus 200 sine of 15. So therefore, EH is equal to 310.58 newtons, and it is rightward. A vertical is assumed to be downward, so R vertical equals 0, equals FBC 1000 cosine of 15, then minus AV, then minus the vertical component of 200, which is 200 cosine 15. So minus 200 cosine 15 degrees, then minus AV. So AV is 1000 cosine 15 minus 200 cosine 15, and that is equal to 772.74 newtons. Finally, force at A is square root of 310.58 square plus 772.74 square. So FA is equal to 832.8 newtons. The elements of a rear suspension for a front-wheel drive car are shown in the figure. Determine the magnitude of the force at each joint if the normal force F exerted on the tire has a magnitude of 3,600 newtons. So here is the figure. We first consider C and B so that we can solve for the force in CD. And let's call the force as FCD. The angle that FCD makes with the horizontal is theta CD, and it is arctan of 60 divided by 220 plus 60, so 280. So theta CD is arctan of 60 over quantity 60 plus 220 or 280. This distance is equal to 90 plus 260, that's 350 mm, minus 220 minus 60, or minus 280. So 350 minus 280 is 70 mm. So that's 70 mm. Then this vertical distance for the moment arm of the horizontal component is 60 plus 245. So that's 305 mm. So again, theta CD is arctan of 60 over 60 plus 220 to 80. So that's 12.095 degrees. Use your calculator. Then the angle that EF makes with horizontal is arctan of 130 plus 60 plus 245 over the horizontal distance is 260 minus 60, so 200. So arctan of 130 plus 60 plus 245 over 200 only. From E to horizontal distance between E and F is 200. 260 minus 60. So that would be 65.308 degrees. So let's consider the components FCD, and let's have the horizontal and vertical reaction components at B. We set moment B0, considering clockwise positive. So equals, the horizontal component of FCD is FCD cosine of 12.095, and the moment arm is 305, and that's clockwise. Then the vertical component is also clockwise, so plus FCD sine of 12.095 degrees, and the moment arm is 70. Then minus counterclockwise moment 3,600 times 165. So it's only FCD that is left here. So FCD is equal to 1898.39 newtons. So we now have answer for the magnitude of force at each joint. F sub C equals F sub D, because this is a short link. So F sub C equals F sub D equals 1898 newtons. Then we compute BH and B sub V. So R horizontal equals 0. FCD 1898.39 cosine of 12.095. That's the horizontal component of FCD. Then minus FBH going left. So BH can now be computed 1856.25 newtons. Then R vertical equals 0. So vertical component of FCD is 1898.39 sine of 12.095 degrees. Then plus 3,600 minus B sub V. So vertical component of reaction at B is 3997.78 newtons. Therefore, the force at B is square root of 1856.25 square plus 3997.78 square. So FB is equal to 4,408 newtons. Then we draw the free body diagram of this portion AEB. Let's enlarge it. So horizontal distance between A and E is 260 mm. Then between E and B is 90 mm. Then we apply the forces, action, reaction. So PH is now rightward, 1856.25. Then vis-a-vis is upward, 3997.78 newtons. Then we have vertical, we have force in EF, which is expected compression. So FEF, the force at E is also the force at F because it is connected with smooth pins. So the angle it makes with horizontal is 65.308 degrees. Then for horizontal and vertical components at A, so let's just assume leftward and upward. So to solve for FEF, we set moment A 0, clockwise positive. There are two components of FEF, horizontal, which has no moment about A, and the vertical, which is clockwise. So only the vertical component of FEF has moment about A. Clockwise positive, so equals FEF sine of 65.308 degrees times 260. Then minus 3997.78 times quantity 260 plus 90, or 350. So solving for FEF is 5923.2 newtons. Therefore, FE equals FF equals 5923 newtons. Then R horizontal equals 0, then equals negative EH plus 5923.2 cosine of 65.308, the horizontal component of FEF, which is rightward, then plus 1856.25. From there, we can solve EH, which is leftward, 4330.61 newtons. Summation forces vertical 0, or R vertical equals 0. So AV equals AV, then minus 5923.2 sine of 65.308, the vertical component of FEF, then plus 3997.78. So vis-a-vis is positive, so that's upward also, 1383.84 newtons. So finally, we can now solve for the force at A. It is equal to square root of 4330.61 square plus 1383.84 square. So FA is equal to 4546 newtons. So that's all for machines, and anyway, there are additional 4 problems on machines, and there are 14 problems all in all. I think that's more than enough for machines.